welcome to SWEC Talks. We are from Sri Vishnu Engineering College for Women. This video is presented by BSL Madhuri with register number 22B01A0521 and G Durga Devi with register number 22B01A0542. This video is presented under the guidance of Dr. M. Prasad, PhD, Associate Professor, Department of CSC, SWEC, Bhimavaram. In this video, we are going to discuss what is a deadlock, what are the characteristics of the deadlock, and how can we prevent the deadlock, how can we detect and recover the deadlock. Means, here in our video, we are discussing four things. This is the agenda of this video. Without any further time delay, let's jump into our topic. Firstly, what is a deadlock? First of all, we should all know what is a deadlock. After that, we will discuss how can we prevent deadlock. So, in this video, we are going to discuss what is a deadlock, what are the characteristics of the deadlock, and how can we prevent the deadlock. First, what is a deadlock? Deadlock is a situation in computer science and operating system theory where two or more processes are unable to proceed because each is waiting for the other to release a resource. If we can observe this diagram, we can clearly understand what is a deadlock. It is nothing but a situation where two or more processes are unable to proceed further because each process is waiting for other process to release a resource. In this diagram, we observe process 1, process 2 and resource 1 and resource 2. Resource 1 is assigned to process 1 and resource 2 is assigned to process 2. At the same time, process 1 is waiting for resource 2 which is assigned to process 2, as well as process 2 is waiting for resource 2 which in turn assigned to process 1. Here we can clearly observe that each process is waiting for the other process to release a resource. So this situation is known as deadlock. In other words, we will define deadlock as a state in which a set of processes is blocked, with each process holding a resource that another process in the set needs, and no process can make any progress. This is deadlock. Coming to deadlock characteristics, there are four characteristics which makes deadlock. Firstly, mutual exclusion. At least one resource must be held in a non-shareable mode, that is, only one process at a time can use the resource. Hold and wait. A process is currently holding at least one resource and requesting additional resources which are being held by other processes. This situation is known as hold and wait. Coming to no preemption. A resource can be released only voluntarily by the process holding it. Circular wait. Each process must be waiting for a resource which is being held by another process, which in turn is waiting for the first process to release the resource. These four are the characteristics of the deadlock. Now, deadlock prevention. Deadlocks can be prevented by eliminating any of the characteristics of the deadlocks. Means by eliminating mutual exclusion and eliminating hold and wait or eliminating non-preemption and by eliminating circular wait, we can prevent the deadlock. Firstly, eliminate mutual exclusion. It is not possible to dissatisfy the mutual exclusion because some resources such as tape driver and printer are inherently non-shareable. Next, eliminate hold and wait. Allocate all required resources to the process before the start of its execution. This way, hold and wait condition is eliminated, but it will lead to low device utilization. For example, if a process requires a printer at a later time and we have allocated a printer before the start of its execution, printer will remain blocked till it has completed its execution. The process will make a new request for resources after releasing the current set of resources. This solution may lead to starvation. Now, eliminate no preemption. Preempt resources from the process when resources are required by other high priority processes. Eliminate circular wait. Each resource will be assigned a numerical number. A process can request the resources to increase or decrease order of numbering. For example, if the process P1 is allocated to R5 resources, now next time if process P1 asks for R4, R3, a process can request the resources to increase or decrease order of numbering. For example, if the process P1 is allocated to R5 resource, now next time if P1 asks for R4 or R3 lesser than R5, such a request will not be granted. Only a request for resources more than R5 will be granted. Detection and recovery. Another approach to dealing with deadlocks is to detect and recover from them when they occur. Means this detection and recovery is done after the deadlock is means this detection and recovery is done after the deadlock is occurred. This can invoke in this can involve killing one or more of the processes involved in the deadlock or releasing some of the resources they hold. Thank you.